I got an Apple Mac Mini with Apple Silicon M1 processor, and there is a lot to talk about, specifically with external display connection and also calibration. So let's get started. I'm Art, and Art is right. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. There are many reviews out there about the new Apple Silicon M1 processor, and most of the reviewers have overwhelmingly been impressed with the performance, and I am too. But rather than taking the machine and the M1 processor through its paces using a synthetic benchmark such as Geekbench or Cinebench, what I'm going to do is put it into a real-world performance benchmark and talk about how does it perform with Lightroom Classic, with Final Cut Pro, with Compressor exporting out 4K videos that I'm uploading to YouTube. So I'm going to use these real-world scenarios to kind of frame this processor a little bit more and really talk about its performance compared to more pro machines that I have in my setup. And obviously, this is going to be much different than other reviews are out there where they're comparing the Mac Mini to a Mac Mini or comparing a Apple M1 processor in a MacBook Air to a MacBook Air. What I want to do is see how this performs against a Pro machine and an Intel lineup currently that Apple is selling. All right, that being said, I'm also going to talk about display setup too, connecting up to the Mac Mini, such as a dual display setup that I have here, talking about the different refresh rate that you're able to achieve with them, what type of connection work, and what are some of the interesting things that I found out about it. Lastly, what I'm also going to do is talk about display calibration, which is going to be extremely important, especially when you're running on a computer. If you really care about color, obviously that is why you're watching this channel right now. So that's going to be a crucial, important thing. And one last thing I'm going to cover in this video is a recommendation. If you are a pro photographer, if you're a pro videographer, we're going to talk about the programs that you have and which computer you may want to consider getting, whether that is an Intel or an Apple Silicon one. We're going to find out towards the end. So let's get going. So let's start by talking about the test system that I have. So the first one that I have is a 2019 Mac Pro. This is a 12-core model. It's a 3.3 gigahertz Xenon processor that turbo boots up to 4.4 gigahertz. It has 96 gigabyte of memory in a 6-stick configuration, so it's running on triple channel memory. It has a Radeon Pro Vega II with 32 gigabytes of high bandwidth memory on there. So it's one of the more pro cards that Apple offer, and it's really an expensive card. And if you have watched my video on the 2019 Mac Pro review, I have mentioned that if I would have gone out and configured a machine again, I probably would not have picked this video card. But nonetheless, it's already in my computer, so I'm going to use it, and I have been enjoying it. It has 2 terabytes of SSD memory, and I don't think that the SSD inside the Mac Pro is quite as fast as the newer one that ships with the M1 processor, but I haven't really done a full test on that yet. The next machine that I have is a 16-inch MacBook Pro 2019. It's an 8-core processor model, so this has been upgraded. 2.4 gigahertz i9, it turbos up to 5 gigahertz. 32 gigabytes of memory. It has the upgraded video card, the Radeon Pro 5500M with 8 gigabytes of memory, and it has a 2 terabyte SSD on there. Lastly is the test meal right here, or our test bench model. It is a Mac Mini 2020 with an M1 processor, and it has 8-core CPU and an 8-core GPU, 16 gigabyte of unified memory, so I upgraded that one, and it has 1 terabyte of SSD inside there. So what I want to do first is let's talk about the benchmark in the different programs that I've used. All right, so let's start out with Lightroom Classic rendering one-to-one preview importing. And what I have done here is run the test 3 times and average the number together. These are 100 Nikon D850 raw files. So these are about 45 megapixel raw files. So these generally push the computer to the limit. With Lightroom Classic right now, it's not running native on the system. So it's running on Rosetta 2 on a Mac Mini M1 because it needs the emulation layer for the time being until Adobe released the full native version to run on there. One thing that I find interesting about the Creative Cloud installer on the M1 machine is that on the Creative Cloud app itself, it says that the program is running in beta, and every time you try to download a program, it says that the program will work, it may not function fully, and you're also running it on an emulation layer. So it's already letting you know about that. But so far, I think the performance is quite interesting. So the shorter is better on this chart. Mac Pro was able to render one-to-one for all these files in about 2 minutes or so. The 16-inch MacBook Pro was able to do it in about 3 minutes and 24 seconds, and the Mac Mini with M1 is able to do in 4 minutes and 13 seconds. So Obviously, because it is not running natively on the M1 processor, these results are kind of somewhat expected, especially when you're dealing with a lot of images. But what kind of surprised me is the next chart up, and this is the Lightroom Classic export. It's really interesting because my Mac Pro was able to export all these files to a JPEG, these raw files to JPEG 8x12 at 240 pixels per inch. My Mac Pro was able to accomplish this in 2 minutes 36 seconds. The MacBook Pro 2019 took 3 minutes and 46 seconds, and the Apple Mac Mini with the new M1 processor was able to do this in 3 minutes and 15 seconds. So that is within a hair length of, I would say, the Mac Pro 2019. This have obviously less cores, have 8 versus 12 cores. And the other thing that I find extremely interesting is that this Mac Mini costs 8 times less than the Mac Pro that I have. And this really gives us an idea of what may happen in the future when Apple releases a more powerful silicon, more core in the system. I have a feeling that it's going to be able to blow the Mac Pro with the Intel processor right out of waters on this one. So it's going to be extremely interesting to see what's going to happen in the future with the new Apple silicon. All right, let's talk about a compressor export in 4K. And the reason why I use compressor and not necessarily Final Cut Pro is that many times my videos, one singular video would go out into multiple different formats, and having compressor there, being able to throw in all the preset and having it utilize multiple cores on the system at any given time is something that I find extremely useful for my workflow. So based on this, what I have done is export a 10-minute 4K 8-bit 420 Panasonic S1 video. And these are multiple videos layered together, cut between different cameras and so forth. It is exported to a 4K, so as I would upload them to YouTube, this is my normal workflow. And this is running on Apple native binary, and pretty much, again, shorter is better. On the Mac Pro is able to compress that 10-minute video in about 5 minutes and 21 seconds. On a 16-inch MacBook Pro, it took about 8 minutes and 43 seconds. But on a Mac Mini M1 processor, it was able to do it in 7 minutes and 26 seconds. My impression about this Apple Silicon is really impressive. Considering that the Apple Silicon is 8 times less than my Mac Pro, and it's able to perform this much on an 8-core system compared to a 12-core Mac Pro system, this is really impressive. In fact, on an equivalent 8-core system, it already beats out my 16-inch 2019 MacBook Pro. There's really not a lot of comparison left to have. I think that these are going to be really amazing machines, and when Apple release their future generation Apple Silicon and their future Macs, it's going to be extremely impressive, and I definitely look forward to that. Next up, what I want to do is talk about display connections. So on this Mac Mini, there are 2 USB Type-C, and the USB Type-C has Thunderbolt overlay on them. It will also output DisplayPort signal on top of that USB Type-C Thunderbolt signal, so that's great, and it has one HDMI output. So the main question that I have is, can I connect 2 displays to this system using 2 of the USB Type-C connectors on there, or the Thunderbolt on there? And the answer to that is no. It will only connect with 1 USB Type-C at any given time. What about a USB Type-C and HDMI? Yes, both will work, so that's kind of interesting. So if you have 2 displays and you want to link them both with a USB Type-C, it will not work. So what happens if you have a USB Type-C output on one of them, and on the other one you have this Apple dongle that converts a USB Type-C to HDMI? Does that change the result at all? No, it pretty much only one display will work, and the priority will be given to the plug that is connected first. So for instance, if I connect this one, this adapter or this dongle on there first with HDMI, it will prioritize this. If I connect it a native USB Type-C or a Thunderbolt to the system, it will prioritize that first. So whatever is connected first, it will prioritize that. Next up is daisy chaining, or Thunderbolt daisy chaining. So I have the BenQ PD3220U. This one supports daisy chaining from a USB Type-C or from a Thunderbolt connection. However, the daisy chaining does not really work on this display at all. That means the Mac Mini does not allow the signal to be daisy chained in that way. What about the refresh rate? I think that this is going to be an interesting thing, and this is extremely interesting where I found out in my testing. I'm going to go over in depth on this in just a moment, but let's talk about the dual USB Type-C first. So only one display will work, and it's display dependent. So it depends on the display that you have to hook up to the system. Again, with a USB Type-C and HDMI, very similar thing. The USB Type-C and an Apple USB Type-C dongle. Again, if you use a USB Type-C, it's going to be depending on the display. If you use a dongle, 4K is going to be forced down to 30 30 hertz refresh rate. The 2K one, you can run it at 60 hertz. And again, daisy chain is not supported on this. So let's talk about all these displays and running 4K signal. And the reason why I'm using majority of the displays that I've tested here are running 4K is because that tends to be more of the display that we're using nowadays. So here's my test bench of displays, the SW321C 4K 32-inch hardware calibrated display from BenQ, this PD3220U 32-inch 4K software calibration, the SW320, which is the 32-inch 4K hardware calibration. This is the discontinued BenQ display model. The SW271, which is right behind me here. This is a 27-inch 4K hardware calibration. And the last one that I've run this test on is the SW270C. That is a 27-inch 2K hardware calibrated display. And again, I haven't tested any other brands or any other display hookup to the system, but this is giving me a lot of data and a lot to really think about. So at the very top there, we have different type of connectors. We have Thunderbolt or USB Type-C. Secondly, we have the Apple USB Type-C to HDMI dongle, which is this dongle right here. And if you're trying to run it on a 4K, it will automatically force the refresh rate down to 30 hertz automatically. At 2K, it can run at 60 based on what I showed you in the previous slide. If you're using a USB Type-C to DisplayPort cable, that is pretty much the adapt cable, one single cable. So one end is USB Type-C, the other one is DisplayPort. That's the cable we're using there, an HDMI cable and the Thunderbolt daisy chain, which the only display that really support Thunderbolt daisy chaining is the PD3220U, which I have here, which I already tested and it doesn't work. All right, so using the major connectors, Thunderbolt USB Type-C, Apple USB Type-C dongle, and the USB Type-C to DisplayPort. Amazingly enough, on the SW321C and this PD3220U, this 32-inch 4K, I'm only able to achieve 4K at 30 hertz. I can't get 4K at 60. I've tried changing different settings for the output on the display already, that the signal is receiving, and it hasn't been working for me yet. When I switch over to HDMI, however, I'm able to achieve 4K at 60 hertz on both the SW321C and this PD3220U. So I'm not really 100% sure, does this have a lot to do with the display firmware itself, or it has to do with just the drivers on the USB-C, or this be updated by Apple in a future OS release? I'm not 100% what's really going to happen here yet. I'm going to do more testing on it and try to find out more. But as of now, I find that this behavior is very interesting, especially when we talk about other 4K displays that I'm going to cover in just a moment. All right, so the other two 4K displays I have is the SW320, which is a 32-inch, like I said, 4K hardware calibrated display. It doesn't have USB Type-C or Thunderbolt, so we're not going to cover that one, not available. But what we have here is an Apple USB-C to HDMI dongle, again, 4K 30, that is expected. But what I find interesting is that when I use a USB Type-C to DisplayPort, that's a singular cable, the adapter cable that I have, it was able to run 4K at 60, very similar to HDMI. This, however, cannot be done on this 3220U or the SW321C. If we go into the SW271, that is a very similar story. But what I also find interesting and what deviates here is that when I'm using a USB Type-C cable or a Thunderbolt cable, it's able to run 4K at 60 hertz on this 27-inch, but it can't do it on the newer 32-inch display. Again, not really understanding what's really going on there. Dongle is the same 4K 30, but like I said, when I use a USB Type-C to DisplayPort and HDMI, I'm able to do 4K 60. So there are some anomalies in the result, but what we can probably postulate from this is that these two displays, the SW321C and the PD3220U, are running on a different type of signal in the system or in the display itself, or a different board with different circuitry compared to the SW320 and the SW271. Again, if you have other 4K display out there, let me know what you're able to find out if you have these machines or if you have their laptop versions. I would like to know what your result is. And lastly, the SW270C, the 2K model, it's able to run 2K at 60 hertz without any problem at all. So I find that extremely interesting. All right, now that we have talked about connection and refresh rate. Oh, and one more thing I forgot to mention is that normally on the Intel Mac with the discrete video card, it will tell you what color depth is outputting at. On these new Apple Silicon, it no longer really reports that, so it's really hard to determine whether this is outputting 10-bit or not. My guess is that it is still outputting 10-bit, but it doesn't really report that in the system information anymore. So another interesting thing there. All right, let's talk about calibration, which is pretty much the pinnacle of this conversation right here, and the new Apple Macs. Again, I'm only able to test the Mac Mini when it's linked up to an external display. I don't have an Apple Silicon laptop, the MacBook Air or the MacBook Pro, so it's really hard for me to test an internal display, whether that would calibrate or not, so that is still pending. All right, so let's talk about this. And first of all, what I like to do is talk about the different matrix that you see there on the top. Does it require Rosetta 2 translation layer? Number one. Secondly, will the program launch? Third column that you see there, does it recognize the display? Will it calibrate? And what's the result like? So starting out with BenQ Palette Master Element, yes, it does require Rosetta. The program will launch just fine. The problem is that when I have the BenQ SW link up to the system, and this is pretty much any BenQ SW, it doesn't recognize the display, whether it is the newer or an older BenQ display. It doesn't recognize it at all. It only shows up as color LCD, which means that it's not really going to have the full communication to the BenQ SW display. What you can do is run through the calibration, but one of the things that I find strange is that it will go through the calibration, but for instance, on the SW321C, it has 3 calibration slots. Palette Master Element will only show that it has 2. That means that obviously it's not talking to display properly. And I've run the calibration in Palette Master Element on a few displays, and what I can tell you is this: the result is pretty much unusable because it's not communicating with the display properly. My guess is that has something to do with the Rosetta 2 translation layer. So the only thing that we can do right now is wait for BenQ to release Palette Master Element that will run natively on these new Apple Silicons so that we can do a true hardware calibration on any BenQ SW displays. So now that we have gone over hardware calibration, let's go over software calibration and see if that is possible. So I have 2 programs from X-Rite, the i1 Profiler and the i1 Studio. Both of them will require Rosetta 2 translation layer. They will launch up just fine. However, they won't recognize the display. And on both of these programs, the i1 Profiler and the i1 Studio, as it stands right now, it won't allow you to go in and calibrate the system. When you try to start the calibration process, it will say that there's no display connected or you need to update the license. So obviously, it's not really giving us the correct error dialog there. My guess is it has a lot to do with the way how Apple is implementing the graphic on their system and the way how it's being output to USB-C. Obviously, we need to wait for the developers, X-Rite in this situation, to update both of these program and code base to run natively on these machines first before we can really go through and run a calibration. Again, I haven't tested this with the Apple laptop, the MacBook Air and the MacBook Pro running on the M1. I'd be curious if you have those machines, if you have these devices, let me know, will it calibrate or not? It'll be interesting to see. So the result is pretty much not available for these 2. The next one though, Spider X. This is what I find interesting. Spider X does require Rosetta 2 translation layer. It will launch. Does it recognize the display? Spider X doesn't really do any display detection the way how X-Rite program does. So it doesn't really go in and have you choose a different backlight technology. You have to manually choose the one on your own, which I guess is a good thing in this situation because you can then go in and calibrate pretty much any display because it doesn't require communication with the display. And it will allow you to go in and calibrate. However, the result is usable, but it's not the best. I mean, what I'm getting is a color shift in a dark tone with a dark tone starting to turn magenta a little bit or green, depending on the calibration. And also every time I restart the machine, the result looks different. So obviously it is usable, but it's not really stable right now. And I don't really generally recommend doing that yet. So let's talk about some more recommendations then for different type of creative. Let's see where we stand and how we can utilize this. So if you're a casual photographer, if you're a casual user, I definitely recommend getting, the Apple Silicon today because they represent a better future compared to the Intel model. If you need a desktop machine and performance right now, the only option that you have at the moment is to get an Apple with an Intel processor. And I still think that those are a great buy today because obviously, if we need to use it now, if you need to use it in your production workflow, it's going to make sense and it's going to pay for itself. But if you can wait, I think that the future Apple Silicon is going to bring some amazing things to both the high-end Pro laptop machine and the Pro desktop machines. All right, for a Pro photographer that has calibration and printing needs, my recommendation is to wait. None of the Creative Cloud app run natively on the Apple M1 Silicon yet. And also the calibration program has gone over, it doesn't really run natively. When you try to connect the display up, depending on which one you have, it may be running at 30 Hertz, so that's not really conducive. So right now, I would say wait. Oh, and one more thing too is that some print drivers are not necessarily fully updated to take advantage of the Apple Silicon yet. That means that you're still running on the translation layer, to which there are some compatibility issues at the moment. If you do casual video work, definitely get one of these machines because they're really great. And in terms of image processing for the price point you're getting, is really amazing. If you're serious about video work, if you're doing this professionally, especially if you need calibration, I would highly recommend that you wait, because none of the programs out there right now that is made for display calibration can really run natively on the Apple M1 and are not able to calibrate this successfully. So let's talk about all of these programs for video editing. I'm going to go in a little bit more on video. Final Cut Pro, again, if you don't need calibration, get it. If you need the calibration, wait. If you're running on Adobe Creative Suite in general, just wait whether you need the calibration or not until they optimize this. I think that this machine is not necessarily a great buy yet. And the thing is that by the time Adobe comes up with an update that will run natively on Apple Silicon, by that time, Apple may end up releasing the updated processor for the new Pro machine, which is going to be really amazing. And lastly, if you're running on DaVinci Resolve, there are some thoughts about that. So if you're running on Resolve, if you don't need calibration, you haven't calibrated before, you can definitely get this. If you run Resolve and you need display calibration, for instance, because Resolve doesn't really do color management and you need the display to be calibrated to Rec. 709, I would definitely recommend waiting. So if you require anything with display calibration, I would just hold off for the time being. So there you have it, my thoughts, perspective, and testing on the new Apple Silicon. Overall, I think that Apple have done a really impressive job. I'm glad that they're able to control the vertical stack fully now and that they're no longer relying on Intel. And I think that the future generations of these Apple Silicon will definitely blow the old Intel Mac out of waters. What I really like Apple to do is for them to release an Apple Silicon GPU so that I can put it into my Mac Pro. We'll see if they end up doing that in the future or not. If they would, that would be great. That will extend the life of my Intel Xenon Mac Pro. If not, chances are I'll probably update it to the new Apple Mac Pro that's coming out with the Apple Silicon sometime in the future. So if you want to know about something, if I haven't covered anything in this video or you're curious about something, let me know in the comments section below. Give this video a like, subscribe if you're new, hit on the bell to be notified every time I upload cool new contents like this. And until next time, art is right.